With this one, it's the same thing. You need to get the constant by itself, the x's on one side, the constant on the other side, and you need 1 to be the leading coefficient in order to complete the square. So the first thing I did here was subtract 6x to get the x's by themselves, constant on the other side. Then I divided everything by the leading coefficient, which was 5. Okay, so you end up with x squared minus 6/5 x equals 8/5. Okay.
Why'd you do that? Why'd you have to do that again?
That's the rules for completing the square. X's by themselves with the leading coefficient of 1. You have to have that in order to complete the square. And once we have that, we just do the same thing we've been doing. Negative 6/5 divided by 2 is negative 3/5, right? Negative 6/5 divided by 2 should be negative 3/5. Negative 3/5 squared should be positive 9/25. So you add 9/25 to both sides. Okay? And then you can easily factor the left-hand side. You know this is a perfect square trinomial. Square root of x squared is x. Square root of 9/25 is 3/5. And it has to be a minus. Okay? Here, in order to add these two, what do I need? Common denominator, which is 25. So I multiply this by 5 over 5. You get 40 plus 9 is 49/25. So are we good up to here?
Sure.
Can you show how you get 925?
Yeah, b divided by 2. Negative 6/5 divided by 2 is right here. You should get negative 3/5. Negative 3/5 squared is 9/25. From there, you take the square root of both sides. We know the square root of 49 is 7. Square root of 25 is 5. So you get x minus 3/5 equals plus or minus 7/5. Add 3/5 to both sides. 3/5 plus minus 7/5. 3 plus 7 is 10. 10 over 5 is 2. That's how I get the first answer. 3 minus 7 is negative 4/5. So your two possible answers are x equals 2 or x equals negative 4/5. Well, the only thing different in this problem is that your leading coefficient was not 1 from what we did before. Okay?
Wait, one more time. I know I'm getting annoying, but where did you get 9/25 from?
Negative 6/5 divided by 2 squared. Negative 6/5 divided by 2 is negative 3/5. Negative 3/5 squared is 9/25. Alright? And this one is asking you to take a equation of a graph, y equals x squared plus 6x plus 2. That's standard form. Take standard form and change it to vertex form, which we've done before. But we can use the completing the square method and probably go a little bit faster. Now with this one, you don't want to mess with the side with the y, so you leave it alone. So you just take the 2 and separate it from the x's. So I left a little space here from the 6x and the 2. Alright, so I'm going to make the x squared plus 6x plus something a perfect square trinomial. So again, I take b divided by 2. What's 6 divided by 2? 3 squared is 9. So I add 9, and since you're dealing with the same side, to make up for that adding 9, you had to subtract 9 also.
Why do you have to do it again?
So you don't even have to do that.
Yes, because I'm making this a perfect square trinomial. So
Then they just eliminate.
I'm separating this part and this part. So now, if you eliminate that, then you're going back to where you
How
were.
can you separate them if they're on the same side? That doesn't make sense.
What are you using that
It's
first?
just like when we factored by grouping. You deal with this part and then that part. What?
But it's still
You don't
the
even
same
use that
equation.
first plus 9, do you?
Yes, I do. Because now I'm going to make this, factor this to square root of this is x, square root of that is 3, plus, and these two simplify to minus 7.
Oh, yeah.
And that's it.
How does the 9 and the negative 9 not eliminate?
If they did
They're in the
eliminate,
same-
they
they're
could
in the same
eliminate.
column.
Right. But if you eliminate them, that's not the point. If we eliminate them, then we go back to where we were. We wanna use
It's not
completing,
like choosing to eliminate them, is how do they just not do it by rule?
they would if you choose to eliminate them. But we're choosing not to eliminate them. We're
Don't you
choosing,
have to eliminate?
no,
Yeah.
we're choosing to factor this trinomial. Just think of the left-hand side, x squared plus 6x plus 9 being one part of the problem, and the plus 2 minus 9 being another part of the problem. We want to use completing the square method to factor this in x plus 3 squared.